Example 4 asks us to find the range of values of x for which 2x squared is less than x squared plus 2x minus 5. So we have 2x squared is less than x squared plus 2x minus 5. So again, we're dealing with a quadratic equation. We don't have this in a standard form for us to work with. Remember, we need quadratics in standard form in order to analyze them. So we want everything on one side and 0 on another. Because I like my x squared term to be positive, I'm going to move everything on the left side over to the right. Or excuse me, everything on the right side over to the left. So when I move the x squared over, I'm going to end up with a single x squared. So I subtract it from both sides. The 2x will become negative 2x, and the 5 or negative 5 will become positive 5. And so when is this less than 0? So in the past, we've looked at trying to find the zeros for these functions. A hint for this, it doesn't always have to happen. Remember, we have equations that can be, because it's a positive x squared, that it can always be positive. It can be positive, or it can be 0 at one place, or if it has to be less than 0, it would have to go through the x-axis twice. One indicator of that is going to be your discriminant. So it doesn't give you the answers, but it can hint at when something can happen and when something else can't happen. You may try and use the quadratic formula for this, or to factor. You won't be able to factor it. Your final value over here, 5, is too large for the negative 2x here. So you're not going to be able to factor it. You could do the quadratic formula, and what you'll end up with are two imaginary answers. So one way to check that is to use our discriminant and figure out, okay, what's our discriminant going to be here? Well, here a is 1, b is negative 2, and c is 5. So if we were to do the quadratic formula and say, okay, well, x is going to equal negative b, which is going to be 2, plus or minus the square root of b squared, which is going to be 4, minus 4 times a times c, all over 2a, which is 2. You'll end up with 2 plus or minus the square root of, this will be negative 16 over 2. Now, right off the bat, you can see that this is not going to have real answers because my discriminant is negative. Now, what that means is that it never actually touches the x-axis. And because this is a positive x squared over here, that means that our graph is always going to be positive. It'll never be negative or 0 at any place. So based off of this information, there are no solutions to this. Now, you can do the quadratic formula, and I would suggest probably doing that just to get the answers if you have them. Just realize that if you get like a long decimal trail, or a number plus another number with a long decimal trail, or anything involving I, when you use the quadratic formula, you are going to end up with no x-intercepts, which, depending on what you're looking for, could mean every answer works or none. In this case, because my graph, and because my equation is when is it less than 0, it's never going to happen here. If the sign had been switched to be greater than 0 at any time, then the fact that we don't have any x-intercepts would actually mean that every answer would work. So just make sure that you're not rushing through and treating this like an algorithm, that there's one way to always do it. You have to step back and look at the problem and think in context of itself what answers are appropriate.